Now, good day, students. Today we are going to look at if statements. Now, if statements are generally called selection statements. You normally have two or more options, and what happens is this that you would try to make a choice. So, if a particular test turns out to be true, then you choose this option. If it turns out to be false, then you choose something else. So that is how the if statements normally work. So imagine you have an option like the other day I went to KFC, and because it was close to curfew hours, it was rather full and they were running out of chicken. So the options saw a few options. For example, my favorite would have been, let's say, Zinger. Let's just say Zinger. So if they have Zinger, purchase Zinger. If they have a big deal, they have big deals or so on, purchase big deals. If they have only spicy wings, they purchase spicy wings. And if I never had popcorn chicken before, so let me try that. So if they don't have any of those, then they can purchase popcorn chicken if they have that. So if you notice, even by the natural speech in English terms, you do a test normally when you have several options, and then based upon that test being true, you carry out the task, the desired option or selection that you want. So remember, you have options and you're making a choice, a selection. All right. So how an if statement works, the syntax normally is, all right, looking at this now, the terms in all caps must be used generally in that order, not chronologically in terms of fact that if, then, else, right behind each other. But say if, carry the test, then do this task. But what if it doesn't work? Then you go else, do this. Another routine can be if you have, let's say, more than three options. It can also be if the test turns out to be, if carry out this test, if the test turns out to be true, then do this. Like in the case of KFC, if they have Zinger, then purchase the Zinger. Else, if they don't have Zinger, do they have big deals? Then purchase the big deals. Else, if they don't have the big deal, do they have popcorn chicken? That's another else if. And if they have that, then you purchase the popcorn chicken. Else, just walk out of the restaurant because they don't have anything that we want. All right. So that is how it works. But one thing for sure, you don't have to use else. But if you do use else, it is going to be the last option you have. The computer will not allow you to carry out any other tasks after else. So we're going to look into that shortly. Now, here are some of the operators that we use. Ignore these two green symbols here, shapes. I only put them there because the next thing we're going to go to is flowchart. So I'm kind of warming you up to that from now. So all of these processes, addition, subtraction, multiplication, division, wherever you have those with a flowchart, they're going to have a rectangle. All right, just remember that. So in a flowchart, whenever you have addition, subtraction, multiplication, or division in a particular line, that is going to be represented by a rectangle in the flowchart. Let's continue. So that is what we call a process, a calculation. However, when we're doing comparisons or relational operators, that now is equal to, less than, greater than, not equal to, less than or equal to, greater than or equal to, those will be represented by a rhombus because now you are not really doing a calculation, you're simply comparing. All right. So let's get into this a bit more because there's one thing I can help you with because even up to in high school, some of my students struggled with less than, trying to remember which one is which. Let's say I put a capital L here, right? If you put a capital L and tilt it just a little, you realize that it looks like the less than sign. That's how I work it out. Yeah, because in primary school and the earlier high school, I had the same problem too. Which one is less than? Which one is greater than? Then I figured it out. Write an L, capital L, and tilt it just a little. It would look like a less than sign. And that's how I wrote that one out. Yeah. Yeah. I did not have the brightest mind in high school, so I had to find simple ways to work for me. And simpler ways, it lasts up until now and it benefits my students. All right. So let's go into a particular situation. Now we're looking at this. The first thing we're going to do, we're going to look at the famous one that we're always using in CXC, you know, working with two numbers. All right. Prompt a user to enter two numbers, then display the larger of both numbers. All right. Simple as that. All right. So now here we enter num1, the name of our program here. Simple if statements. All right. And we declare three variables, num1, num2. And those are the two variables. Did I say three variables? I think I said three variables. We declare two variables, num1 and num2. And then we declare them as integers, whole numbers, positive or negative, doesn't matter. And now we write to the screen. We start to write our code now. Write to the screen. Enter the first number for comparison. The person enters num1. Enters a number, we assign that as num1. Then we write to the screen again. Enter a second number for comparison. We read into the variable num2, num2. And then now we start our code. If num1 here, if num1 is greater than num2, then begin. So you say if num1 greater than num2, then I will say begin. What should we do? We would write to the screen num1 is greater than num2. And then we end this if statement here. Now you notice a different kind of end here. You have three ends in this program. You have end, regular, nothing, no punctuation. Then you have end, semicolon, and you have end, full stop. Right? So this end statement, just simple end, no punctuation after it, is simply to end this if statement here. Just to end this section of the if statement. Just this section alone. Now we go else, because if num1 isn't greater than num2, we can figure out that num2 must be greater than num1, right? We can map that out, right? So we write to the screen, num2 is greater than num1. Let's run this program, all right? And let's see how it works. Enter, a little bit smaller so we can see a part of the code as well. Enter the first number for comparison. Let's enter 7 here, and then let's enter 4. So which one is greater? Num1 is greater, right? So we say num1 is greater than num2. All right, cool, good. But let's run this again. And I'm going to put this into a loop right now. So we're going to run every time. Let's run this again. So now we enter, let's say we enter 7 again. But this time for the second num for num2, we put 9. Num2 is greater than num1. So we see all of the program does work. It is working. But let's run this now and see what happens. Let us say we have 6 here and we have 6 again. All right. So we have 6 for both situations. Num2 is greater than num1. Why would it say that when it in actuality is not true? All right. The computer did a test. Was 6 greater than 6? Because we entered 6 for num1 and num2, you know. So the computer reads, is 6 greater than 6? No. So it just went straight to else and do that task. And then end with end semicolon here, and the whole if statement cycle. The program was done. So this test didn't work out to be true. The computer did not bother to evaluate if num2 is greater than num1 because we did not ask it to do a test. So now we realize our program has a little bug. All right. In other words, no syntax errors because it runs. So it's free of syntax errors. It ran perfectly fine. But we have a logic error because it's not producing the right results. So now we have to modify this, and now we say else if num2 is greater than num1, then begin. We'll write to the screen num2 is greater than num1. But as we saw before, we can also have the situation where it is equal. So now we can write else now because it's the last condition we're going to check for. Begin. And now we write to the screen, write ln, open bracket, because if num1 isn't greater than num2 and num2 isn't greater than num1, the only other option that exists is they must be equal. So now we can write to the screen, both numbers are the same. All right, and then we end that. And now we put an end semicolon here because all the if statement construct is going to be ended. All of this here is now ended down here. All right, let's run this and see what happens. All right, our program is running. All right, so we already know that num1 is greater than num2 and num2 is greater than num1. Let's see if they are equal now. 6. What's going on here? 6. Whoa, something is happening here. Not sure what's happening. Server issues. Let me copy this. Control A, Control C, and refresh the page. So I can just paste back my code there. Reload. Put this away. All right. Control A, Control V, put that in. So this is the last code that we're working with. Let me get this out of the way now. And let's run this. And let's see what we get for the answer. Now we have 6 and 6. And now we get both numbers are the same. So now our program is working perfectly fine. So this is how we can actually write the code to evaluate two numbers. By extension, we can do the same process if the numbers are smaller, which number is less than which. All right. But there's something I want to make clear. Usually in writing these, there is a issue, a challenge. All right. Because what if the user enters negative numbers? All right. I'm going to get into that right now shortly. Let us see now. Now we do it two numbers. What if we have a series of numbers? Let's say 5, 6, 7, 8, or even 100 numbers. We're not going to do 100 numbers, but let's say we have a lot more numbers. This simple construct won't work. So let's look at another way to get this done. Let me open another project. Let me cancel. Let me save this. Save it. And I'll open another project. All right. And I'll call it largest number. And put this back to the side. Okay. So here is what we have now. We have declared var. We have declared num as integer. So we're going to put whatever number we're going to enter is going to be placed inside num. I put this here loop number, in other words, to tell you which number loop we are. All right, let me put this to 5 here, so. All right, so we're looping 5 times, a for loop. And we initialize largest to 0 because it's good to initialize your variables. Now, if the user enter negative numbers, we're going to have a problem now because 0 is going to be the largest number. So hence I put the term enter a positive number for comparison, because there are ways you can break these programs, so you have to make allowances, right? And we can actually write the command that enter a positive number. All right, but anyway, let's continue. All right, so we put this, start the loop, the for loop now. For loop number therefore equal 1 to 5. So I'm going to loop 5 times. Write to the screen, enter a positive number for comparison, and then we read that number. Now here's what we go now. What we do. Remember, this section here, how we initialize large, it's at the beginning. It's outside the loop at the beginning of the program, right? So largest is 0 here, and the person enters a number. We put that into num. Now we say if num is greater than largest, then what? Largest therefore is going to be equal to num. So therefore, once the number is bigger than largest, and largest in the first instance is 0, then what will happen is that the largest is going to become that number. And I say this is the largest number so far, and we end it. All right, I will say else, we end this section, but the entire if statement is not finished yet. Else begin, the number you entered is not the largest number so far. We could do something else. We could actually do a test here to kind of rid ourselves of any errors. So we could say else if num is less than 0, then we begin. We tell the person, let's be a little bit cheeky here. All right, let's be a little bit cheeky. Let's be a little bit rude. You can't read. Oh, you can't put an apostrophe there. Can't read. All right. We told you to enter a positive number. All right. So that is our cheeky way of saying no. That's rude. Hope you guys don't do anything like that when you're writing your code. All right. So now this is a safeguard. Say person enter, try to break our program. We made an allowance for that. So if the number the person entered is less than 0, all right, we could even say less than or equal to 0 as well. Could do that. Then it gives them a rather rude awakening. All right, let's run this and see. All right, enter and now a positive number for comparison. So let's say we enter 4. All right, this is the largest number entered so far. 4. Okay, enter a positive number. Let's say somebody try to be cheeky and try to break our program. So we say negative, any number, negative 5. Oops, that's positive. So enter negative 5. You can't read. We told you to enter a positive number. All right. So let's say enter a positive number. Let's say 9. 9 is the largest number entered so far. Let's say 7. And then let's go again. Let's say 3. And then we see the largest number entered is 9. Our program ends. All right. So therefore, this is how we write a program wherein we have a series of numbers and we want to test to see which is the largest number entered. Yes, I entered a little bit more code, not even a little bit more, but a lot more code than was necessary. Yes, we could make the program more efficient. But you know, you try to, let me get rid of this end full stop here because we don't need 2 end full stops. All right. But you know, it's nice to kind of spice up your code and make it kind of interesting. But of course, in an exam, you just do what is necessary. So this is how we write the program to test numbers and then to produce the largest number. The next video we're going to look at after this is if statements, and it's almost, I want to use the term grouping because we use it a lot in spreadsheet and especially in database. How if you're counting by parishes or a district or a country or a region and you want to see the total for each region and the amount of entries per region. We're going to look at that as well because then you have to have an if statement to look at that. And we are going to look at that and see how we can best work that through. Now, when you're learning, young people, do not take shortcuts. All right? Spend the time, figure your code out, map it through, and be diligent with it. Now, remember, you are going to make mistakes. I'm still making mistakes, and I've been coding now for over 30 years. Yeah? And I still make mistakes frequently. To become a good programmer, you have to learn to correct your errors. So if you make a mistake, that is normal. That means you're on the process of learning. If you want to move beyond that, well, you're not going to ever move beyond making mistakes, but you can pick up your mistakes easily, is to learn to fix your mistakes. So do not crush your paper up and throw it away or discard the whole code. Becoming a better programmer is automatic. You have to learn to correct your coding. All right, have a good day, guys, and this ends our first video on if statements. Next time we're going to look at if statements again, but more by regional grouping. All right, thank you very much. Have a good day.